basically today I'm talking about InfluxDB, which is the new core of the database being written in Rust. It's an in-memory object store backed columnar database built around Apache Arrow. So the talk flow is something like this. We're going to talk about a little bit about the project goals and the highlights, data organization and technologies that we're using, the API, and I'll close with the path to release. Let's see. All right. So the project goals. This is a reminder about what we consider to be the key goals for this project. There's a long laundry list of features and desires that are above and beyond what I'm about to cover, but these are the big highlights. So obviously we want it to be good for time series, but also events. So metrics and measurements, whether that's sensor or server data. Tracing data is a big use case, but really any kind of event data that you can think of, and logs, and which basically we think of as like semi-structured events. We want IOx to be a great backing store for any of this kind of data, which we view all of this as basically different views of time series. Obviously, it has to be good for dashboards and monitoring, which is what InfluxDB is currently great for, but we also want it to be even better for analytics and doing analysis of the data that you have at scale, regardless of the cardinality of that data. Essentially, like, we want people to be able to write data into Influx without thinking about whether something's a tag or a field, without thinking about whether something adds to the number of series that they have in their database. You should be able to have something as a tag that basically is unlimited cardinality. So tracing is a great example here, where if you're writing tracing data in and say span ID is one of your tags, it means literally for every line that you're writing into the database, you're creating a new series. And we want it to work well for that. The other big item is decoupling compute from storage. That's for a few different reasons. One, we want to be able to scale the query workload separately from the storage workload. We also want the storage to be expandable on its own. So we want essentially to have infinite storage and take advantage of that and be able to spin up servers on the fly to be able to connect to the storage system separately. Bulk import and export is a really big item. So bulk import is important, obviously, for historical backfill, but we also view bulk import as important for operating at the edge paired with a cloud service or a central service in your data center. You should be able to collect that data, say, over the course of a day, and then once a day, upload that data in a bulk format where it's much more efficient than, say, feeding in line protocol line by line. Bulk export is great because you can build all sorts of like backup and recovery tooling, but more importantly, if you're doing machine learning and you want to use Influx as a backing store, bulk export is a need that you have if you're going to be doing any model training or anything like that. So that'll be useful for that. Also, user-definable replication and subscriptions. Users should be able to connect to the data store and say, I'm interested in this data, and get a real-time feed of that data as it comes along, or periodically pull for that data. There's going to be an embedded JavaScript scripting engine. We want people to be able to define complex processing that lives as close to where the data is collected as possible in a language that they're probably familiar with, which is JavaScript. And lastly, it's important for us to have broader ecosystem integration. We want IOx to be useful to pair up with a bunch of other different tools. So that's where these other technologies come in, where we want it to be easier to hook up data science tools that you use every day to big data and analytics processing systems that you may be using. All right. So the other thing as we're building this is that it's important for us to think about where IOx is going to be deployed. This kind of informs how we're creating it. So the first obvious thing is the public cloud environments, AWS, GCP, and Azure. We currently operate in all three of those environments, and IOx needs to do so as well. And it needs to be built from the very beginning to operate within Kubernetes, within basically a highly ephemeral environment with containers coming up and down. And it needs to be able to run inside that. Obviously, we have to be able to run within a customer data center as well for situations where people either can't or won't run within a public cloud. And then lastly is edge devices, right? Whether it's some smaller ARM device or it's basically just a server that's out on a boat or something like that. We need to be able to operate at the edge seamlessly with our centralized cloud service. All right. So some of the highlights I think that are important about InfluxDB IOx. One, as I mentioned, it's an in-memory columnar database, but it also uses object store for persistence. Specifically, it uses Apache Parquet, which is a persistence format. The combination of the in-memory and Parquet format give us the ability to create a system that has much better performance characteristics than the previous version of InfluxDB. Importantly, it supports SQL as the query language, specifically the Postgres dialect of SQL natively that's built into the system. But we also have Flux and InfluxQL support through essentially an API that we built out where you have the Flux and InfluxQL processors that are written in Go that hook up to the Rust process through this API to be able to provide end-to-end support for those languages, which obviously we are going to continue to support in addition to SQL. So the other big item, which Evan kind of mentioned when he was speaking, is that it's built around Apache Arrow. Arrow was started in 2016 by Wes McKinney as an in-memory columnar data specification to help data scientists do fast, zero serialization, zero copy data interchange between different platforms and languages. It then expanded into persistence formats by adopting Apache Parquet, which is a compressed columnar and nested data structure format. And like I said, we're using that as well. Next, it moved into RPC by defining Apache Arrow Flight, which is a gRPC layer that uses flat buffers for metadata and like metadata description like schema. And it sends the raw Arrow data to define a highly efficient and fast data interchange over the network. And this is basically a native protocol that IOx speaks already. Now, in the specific language implementations of Apache Arrow, you have compute kernels for common vectorized computations. And in Rust specifically, there's a project called Data Fusion, which is a SQL parser, planner, and executor that follows the Postgres SQL dialect. And this was contributed to Arrow by Andy Grove in 2019. So despite Arrow's relative youth, it's starting to get significant adoption in the data science and OLAP databases. Snowflake, BigQuery, Redshift, and others in the data warehousing and big data space support either query and data egress via Flight or bulk data ingress and egress via Parquet. This points to a potentially promising future where data persistence and network interchange are standardized for OLAP workloads. I think that this could do for data warehouses and data lakes what ODBC and JDBC did for OLTP relational databases. This I've mentioned a few times, which is it's written in Rust. Now, I've written about my excitement for this language over the past couple of years. I think Rust is the future of system software. It gives us fine-grained control over memory that we're looking for, but with the safety of a higher-level language. Even better for us, it's modeled for programming concurrent applications, which most server software, and obviously this project are, eliminates data races. Within our Go base, this has been a source of a number of very hard-to-track-down bugs over the years. Rust's error handling also helps developers write correct software and reduces the number of runtime bugs that you might otherwise create. Unfortunately, we all create bugs if we're writing code. The other nice thing is that it's embeddable into other languages and systems. This means that we can embed it into InfluxDB or other parts of our stack or other analytics systems. We can embed our query engine into any language. We could even compile it down to WebAssembly and run it in the browser if we wanted to. Now, there's so much to love about Rust, but this talk isn't about that. But ultimately, I want this project to form the basis of future analytics systems for the next few decades and beyond. So choosing Rust as the implementation language is a big part of this forward-looking bet. Now let's look really quickly at the Rust Arrow library called Arrow RS. It recently moved into its own repo out of the Arrow mono repo. Recently, like within the last 30 days. This makes it easier to integrate the Rust bits and allows it to have its own release cadence outside of the longer release cadence of the bigger Arrow project. As of only a few days ago, it's been finalized that the Arrow RS crate will have a release every 2 weeks. This is great for Rust developers that want to use it. So if you want to check out Arrow RS, I highly recommend that as well. So the different components are what's called the record batch and compute kernels. A record batch is basically a block of Arrow data. Then we have the Parquet reader and writer to read and write Parquet files. We have the Arrow Flight RPC layer. And then lastly, we have Data Fusion, which is that SQL parser, planner, and executor. And as we're developing IOx, we're contributing to all of these portions of Arrow RS. And in fact, one of the members of our team, Andrew Lamb, is now on the PMC committee or whatever it is for project management committee for the Arrow project. Now, I would be remiss if I didn't talk about licensing. This is a kind of a hobby horse that I get on occasionally, but I think it's important to mention that it's open source. Evan mentioned this, but I'm going over it again. It's dual licensed under MIT and Apache 2, which is common within the Rust ecosystem. The reason I think it's so important to be upfront about how we plan to commercialize all of this is because of all the changes in the open source world, people switching licenses and stuff like that. We want to keep IOx permissively licensed open source, which means we need to have a good plan for how we plan to turn it into a business. Now, our business is in the operating and management of many IOx servers. So IOx is basically an open source data plane, and we are building out a control plane, which is a totally separate piece of software for our own cloud environment. But the important part of this strategy is that we will be running in our cloud the very same open source bits that we're releasing out into the world, the open source builds. So those open source Docker containers that we'll be producing later this year are the same containers that we run in our production environment. And that's a key part of our strategy, is that we want our commercial software to be complementary to the open source software so that open source users can either choose to use it or not, but there's nothing within the open source, there's nothing there that gives us advantages that the open source users don't have, other than the fact that we're the ones hopefully bringing as much development velocity to the project as possible. Now, this is how data is organized in IOx. It looks like a normal relational database with tables, rows, and columns. At the top, you have a database. In our example, this is TelegraphDB. Below that, you have partitions. Now, how data is split out into partitions can be configured by the user when they create their database. Rows that get written into the database only exist in one partition. Now, within each partition, you have the tables, and beneath the tables, you have chunks. Chunks exist to organize data as it comes in so that old chunks can be made immutable. Now, the entire goal of this structure is to split data into large immutable blocks that can be kept in object storage and, importantly, removed from consideration for certain queries. Now, I say it's immutable, but we'll obviously have to support upserts and deletes, but the expectation is that those operations are not the norm. Now, obviously, InfluxDB has a slightly different data model than IOx, so here's how we're mapping its model to IOX's table model. So obviously a bucket equals a database, a measurement equals a table. A tag is just a column within a table. In this case, we dictionary encode those columns. A field is just another column. So it's important to note that tag keys and field keys can't be the same within the same table or measurement. And then lastly, we have time. So here we have the first screenshot of the presentation. So I wanted to show something that we have working. So we have a SQL REPL for IOx. Now there's a bunch that has to work just to show this screen. First, there's an IOx server that I have running on my laptop. I have Telegraph writing data into it via the InfluxDB 2.x write API and line protocol, which IOx can accept. We have a SQL REPL wired up. It uses the IOx Rust client, which we have as a separate crate in the project. And we aren't publishing it to Cargo just yet, but when we get to the point that we're creating usable builds, we'll have that available. The client connects to the server I have running locally. Show databases uses the gRPC API, which I'll talk about in a bit, to get a list of the databases that the server has. Next, you see me do a show tables command. Remember, I mentioned the Apache Arrow flight RPC for fast data access. This sends a SQL statement over that API, gets the result set back as an Arrow record batch, and shows it pretty printed here on screen. You see a number of tables listed with different table schema. Everything as IOx is data that I've written in, or Telegraph has rather. The system tables are built on the fly and return useful information about this database and its operations. We'll come back to these later. And the information schema table gives details about the schema of the database. Now we have an actual query against the underlying data. You see a familiar SQL statement. We're asking for 10 rows from the CPU table, and you can see that the tags CPU and host are listed, followed by the time, and then the individual fields that Telegraph writes in. All right, let's get back to the architecture. This is what I call object storage. One of the biggest design choices for IOx is that it operates with object storage as its persistence layer, as its primary persistence layer. This is the decoupling compute from storage, and we needed a system designed to run in a highly elastic and ephemeral environment like Kubernetes. So the easiest way to do that is to use object storage as our persistence layer. So we treat it basically like a big file system in the sky, albeit one with limited capabilities compared to a local file system. Now, this approach has been written about pretty extensively. There are research papers that came out of Snowflake and a few others, but the Snowflake papers, I think, are the ones that are most interesting in this space. So we're following that kind of work. Now, we still have to be able to run without object storage because we need to be able to run at the edge. So we have a common object store API within our code base with concrete implementations backed by the local file system, by memory, S3, Google Cloud Storage, Azure Blob Store, and other services with compatible APIs like Minio and Ceph. So this means that IOx can run without a locally attached disk. It can run entirely in memory. Now, this is actually the goal of the project, given some of the other features that IOx will support, like replication, real-time data subscriptions, and an embedded JavaScript engine. You can use those pieces of technology with just the in-memory processing system. So let's look at how data is organized in the object store by IOx. Here's an example directory structure. At the top, we have a writer ID. Each IOx server that is pointed to an object store bucket is required to have a unique U32 identifier. We take advantage of this property and have single writer, many reader semantics across a collection of IOx servers. It means an IOx server can write into the object store knowing that it owns that space, but any IOx server anywhere that has access to the object store can read those files and actually mirror the data that's landing in the object store as it comes along. Next, we have the database name. Then we break data out into partitions. As I mentioned, this structure is defined by the user when they create a database, and we have a default partitioning scheme that just creates a partition per hour. They can partition data on table, on some value of the data, or any number of ways. In this example, we're partitioning by year and month, but like I said, by default, we actually partition by hour. And beneath that, we have what's called a chunk. These are immutable blocks of data. We create new chunks as data is written in, and we use this as a way to buffer up as much data as possible before persisting it to Parquet. So finally, we have a table. Now, we're likely shooting for individual table sizes in the tens of megabytes each. So not too big, so we can quickly pull an individual table file from object storage, but not so small that we have like an insane number of small files like scattered around. So I should note that we haven't really talked about indexing yet. Where does this happen in IOx? Well, other than partitioning the data and organizing it into immutable chunks, we don't really index. When data is collected in memory and written out to Parquet, it's obviously sorted, and it's encoded in a number of different ways. But the strategy is to organize data into partitions and prune out most of that at query planning time. Then when the query happens, we brute force the small number of partitions that are relevant to the query. What this means is that cardinality doesn't have nearly as big of an impact on the storage footprint or the memory footprint. The difference between IOx and InfluxDB is dramatic. So let's talk about the different IOx components from a high level. We have the write buffer, which acts as a log of updates to the system. We have the mutable buffer, or what we refer to as the MUB, where queryable data lands in memory initially, where it can be appended to. Then we have the read buffer, or the RUB, which is an optimized read-only memory buffer that uses techniques to reduce memory footprint of data and speed query execution. And finally, the catalog, which keeps track of all the Parquet files in object storage for a given server, along with summary information about those files. This makes it more efficient for an IOx server to know what it has in object store and to use that data to prune out partitions. Now, our efforts at the moment are primarily focused on the MUB, the RUB, the catalog, query functionality and performance, and the movement of data to and from object storage. This is the IOx read path. As real-time ingest happens, it lands in the mutable buffer. The MUB and the RUB together basically represent the in-memory database. Over time, data is transitioned into the read buffer to achieve better compression and faster query execution. Data fusion, as the executor, will push down specific operations that it can to speed things up. We'll be improving this over time to take advantage of the read buffer's capabilities as they expand. Predicate pushdown is the first thing in the list, and that'll be coming very shortly. So here are some of the techniques that we're using to reduce the memory footprint of data as it lands in the read buffer. So dictionary encoding, I mentioned before, which is basically taking, the individual string values of tags, for example, and mapping those to an integer. We also have run length encoding to encode repeated values, which is really important for, say, lower cardinality tags where we can save a bunch of space. Byte trimming, which is basically using only the number of bytes you need to represent the precision of an integer or a natural float. So, logically, the integers that Influx supports are, int64 or uint64. But if you're only writing in numbers that can be represented in a U8, that's what we use. Frame of reference encoding. This isn't something we're doing yet, but it's something that will be coming soon, which is basically if there are a bunch of values that are very high number and we can have an offset that applies to all those values to reduce the number of bytes that we need for the representation of it. And then the other big thing that recently got added is a more efficient handling of nulls. Now, this is important for sparse tables, which we discovered through our own production dogfooding of this system. So I wanted to show this because I think it's pretty exciting. The system of tables I mentioned earlier give us a look into the shape of data within IOx. So here we have a query that shows off a number of things all at the same time. We have count, sum, we have some math selecting from a system table, and we have a grouping on multiple columns and in order by. All of this stuff is wired up. Now this system table keeps information about the chunks in the database. Importantly, it gives us information about their sizes. So here we have the result set. We can see that there's a partition per hour for each of the tables. We can also see what the size in megabytes of that data is, and this is the size they're taking up. Now I find this exciting because not only can you see how much functionality is already there, thanks to data fusion and the other pieces, but you can start to see some of the telemetry that we're building into IOx early on. We want to give visibility into how much space different tables are taking, how much space their rows and columns take, and other things that tell you about the shape of the data and help you operate more efficiently. So this is a dashboard of the read buffer of the system that we have running that's mirroring one of our production workloads. So we're running IOx to mirror this production monitoring setup. Now in this case, we're looking at the summary of a small slice of data from this IOx server in a real-time dashboard. And we can see how many columns there are, the space they're taking, the number of values in millions, and the bits per value and the sparsity of the data. Sparsity represents how many nulls there are in those tables. Now, we found through this production dogfooding that we had some tables that were very, very sparse, like greater than 90% sparsity. So we needed to make an improvement to optimize for this case. Getting this type of real-time visibility into the shape of the data going into IOx, I think it will be really invaluable and help people operate it. So here we have a dashboard showing the bits per value. And we can show the compression that the IOx server is getting in real time before and after the improvement for null representation was deployed. Before it, we were taking about 44 bits per value on average, and after it, we see that we're taking 18 bits per value. Okay, now let's get to the API of IOx. We have three main areas: write, read, and management. So on the right side, we obviously, as I mentioned before, have the InfluxDB v2 compatible HTTP API with line protocol. We also have a protobuf definition that we're creating so that you'll be able to post those protobuf bytes to just a /write endpoint, HTTP endpoint, or a gRPC service definition so you can connect that way. And we're going to have bulk import via Parquet. So one of the ways this might work is you can write the Parquet files directly to IOx and it will put them in the right places in object store and gather everything together. Or you could potentially write those Parquet files directly to object storage and then make a separate API to IOx when you're done to tell it, here are the files I've just written to object storage, put them into your catalog. On the read side, we have, we have obviously HTTP GET that lives at /IOX/API/v1/databases, the name of the database /query. There are two query parameters, queue and format. Queue is just the SQL string, and the formats we currently support, you can ask for are a pretty printed format, CSV, or JSON, and this all works today. We also have the Apache Arrow flight API where it has a thing called do-get, and you pass it a JSON encoded object that has the SQL query string in it, and you get back a record batch. So the other big piece is managing the IOx server. We want anything that you would need to do to operate and manage a production instance of a server to be accessible via the API. We need this functionality ourselves so that we can build this control plane that I was talking about in our cloud environment. So all of this is through gRPC. Everything is defined in gRPC. But for people who don't want to use, a gRPC client, you can also do everything through a command line interface that essentially calls out to the gRPC layer. You can create a database. You can manage the lifecycle rules, persisting to object storage, evicting data from memory, and loading from object storage. And you'll be able to define subscriptions that will send data out in real time to either IOx servers or other servers that you've built. All right, the road to release. Now, obviously, the first big thing is dogfooding this in production. We're currently doing this, and we're going to expand our production usage of IOx over the coming months. We'll need to do a lot of optimization. Obviously, I've already talked about some of this with the null representation, the memory footprint, but we also have to optimize query execution, and we have to optimize the recovery time from object storage for a server restarting or a new server coming online. After that, we'll make it available in InfluxDB Cloud for new customers or new buckets that you create. Our goal is to have this available in Q3. At this point, we're building towards that goal. So after that, we'll want to build migration tooling so that we can, for people who opt in, we can automatically migrate buckets from the previous storage system, TSM, over to IOx as the storage system. And the way this will work is it'll be completely seamless for our cloud customers. There will be a zero downtime migration. It will happen in the background, and then a changeover will happen. And we'll be running both systems in parallel at the same time to ensure there's no interruption in service. And if anything goes wrong, we'll have the other hot system to fall back on. That's the nice thing about deploying and operating this in our cloud environment to begin with, is we can build those kinds of tools and those kinds of controls so that we can ensure a smooth experience. And then finally, after that, we'll be writing up documentation, creating the actual Docker builds, and cargo crates. So we're thinking right now that the builds we're going to offer are essentially just Docker container images for the different environments or different architectures, and then obviously the cargo crate. So if you want to find out more about the project, there are a few different places you can go. We hope you'll join us in the InfluxDB IOx in our community Slack. We also do a tech talk every second Wednesday at 8 a.m. Pacific time, which is 1500 GMT. We also record those talks. So the previous talks are on our YouTube channel. You can access those. We had one last week that was about the catalog. It was like a deep dive into the catalog and talked about some of the other technologies that we evaluated as we were developing that. And then lastly, obviously, there's the IOx repo itself. So with that, that is all I have. I'm not sure if we can do Q&A or...
Yeah, we are going to do Q&A, but before we do, I just thought we would just reiterate a couple of points that you brought up. So as Paul mentioned, we do community office hours, and I was just looking at the talks that you and the team have done since December. So you made the announcement in November, and starting in December on a monthly basis, you guys have been doing the community office hours. And what's kind of fun is like just looking back at that, you can see that the team and you have made some tremendous progress in the last couple of months. I'm sure when you're deep into the project, sometimes it doesn't feel, quite as impressive as it is. But I just wanted to remind the audience, as Paul said, all the talks, all the presentations, the videos are there. And we do want to encourage everyone to join these sessions because it isn't just you talking, right, Paul? I think you've actually introduced Andrew on that talk. I think Ed talked on one of the sessions, Marco, maybe there was a couple of other people. So they can also bring their experiences to the table. And as Paul mentioned, we do this on a monthly basis. So Paul, my first question to you is, hopefully you've had a little bit of time as you were building out today's presentation to reflect on the progress that you guys have been making. What are some of the kind of exciting things that that happened in this project in the last 6 months that you just weren't anticipating? Or was everything just laid out as you already have been thinking about this whole time?
Well, so one thing I wasn't anticipating was how quickly we would scale the team out. So when we announced the project in November, we also announced that we were hiring for the team, and we had really an overwhelming response of people interested in working on it, both because it was written in Rust and also because of the core idea of what we were doing. So essentially, initially we were only going to add a few people, but we found so many great people. And at this point, the team is 10 developers, but you can't really count me. Maybe you can. So 9 or 10 developers, depending on how you view that. So yeah, that's basically, up until November, it was Ed, Andrew, and I. Then we added Dom to the team, and then into the new year, we added a bunch, Marco and another Marco and Raphael and Na. We had a bunch of people. So scaling up the team as we've been, in this project pretty early has been interesting, but it's working really, really well. So I'm excited about basically the velocity that we're getting, honestly, just within the past 30 days because of the team size. On the technology side of things, Ed, Andrew, and I basically were doing a bunch of research and debating a lot of stuff like for the majority of last year. And initially it was just Ed and I at the very beginning of the year, and then Andrew joined us. So over that time, we wrote a lot of code and did a lot of research. And we kind of landed on these technology choices, later in the year. Obviously, by the time we announced the project in November, and those are pretty fixed, right? We knew Rust is the implementation language. We knew Apache Arrow. Data fusion was something we were actually debating, and seriously, we're considering options there. But we landed on that and settled on that over the summer. So from a technology perspective and from a capabilities perspective, I think it's been pretty consistent since November.
And so how has the community reaction been from the Rust, Arrow, Data Fusion side? Any feedback from that team? Are they excited that you guys are making these contributions?
Yeah, so honestly, everybody, from what I've seen on Twitter and stuff like that, everybody from the Rust and Arrow community have been super, super supportive. So the Rust community, obviously, they share Rust projects that they think are interesting. So IOx has been on the trending GitHub repos within Rust a number of times, and then the Arrow community, I've known Wes for a long time, and he's known of our interest, InfluxDB's interest in Arrow, since we contributed the Go implementation of Arrow years ago. So we'd been contributing the Go version for a while, but the Rust Arrow community specifically was very welcoming. I actually reached out to Andy Grove, who created Data Fusion, at some point early last year to tell him about what we were building and to ask him what he thought about it. And he was very generous with his time. He does this in his free time, not as his day job. So he was more than happy to talk to me and obviously work with our team as we started contributing code. So I think the decision actually to build with Arrow, I think, has been very, very good because there's a broader community that's contributing to that and adding features, right? So we're getting new features in Data Fusion for free because other people are contributing to it. And that's part of what we had as the vision for this project. So I think it's been very good.
Cool. With some of the goals that you stated earlier, you talked about unlimited cardinality. What are some of the use cases that triggered that? And why did you think that was important?
So the obvious use case is tracing. But even before you get to tracing, if you look at many of the different time series solutions, like all the Prometheus stuff, different solutions, Influx itself, the user guides all tell you to worry about your series cardinality. They tell you to think about, what tags you're writing in, right? And for me, like, this is a less than optimal user experience. I want you to be able to basically just like write data into this system and then query it out and make sense of it later. The only goal is that you actually have the data structured in some way. So even before you get to create, use cases like tracing, which are essentially degenerate use cases for cardinality, cardinality becomes a thing that you have to worry about and think about. And we just wanted to remove that from consideration. We wanted people to be able to write data in and not have to worry about it. But like I said, tracing is a big one. I think behavioral analytics is a big one because you see high cardinality there. Network monitoring, if you're doing like point-to-point network monitoring, that ends up being really big. People are monitoring DNS servers I've seen before is a really big one. Yeah, there's a bunch of different ones, I think.
Yeah, and I guess it really matches with your philosophy of time to awesome. I mean, instead of having to really worry about these things, like you said, right? You just want people to get up and running, just start writing data in, not have to think about what the structure should look like, what are the unknown kind of rules. You just want to let people just kind of go as quickly as they can. And so I think the other question I have is you talk about decoupling compute from storage. And I know in some of the other talks, you talked a little bit more detailed on that. So what was some of the kind of, I guess, the use cases behind that? What were some of the reasons that some of the community members led you down to that path?
So I've been paying attention to this kind of stuff. I mean, I think the first I had seen from this was when Athena launched. It was based on Presto. So Athena is Amazon service where you can query like data inside S3 and you can have SQL queries that process it. And it's more focused on queries that take a longer time to process and large scale analytics. So I remember seeing that. And then I remember Snowflake, they were really good as they were developing their platform, even though it's entirely closed source. They wrote up papers as they went along that were contributed, that they presented at the VLDB conference, which is the very large databases conference. And their papers were always super interesting. So I followed those. And basically, like, it's a few different things. Like I mentioned, you want to be able to scale your compute workload separate from your storage workload. But it's really nice when you think about splitting out your different production kind of profiles of what you're doing, right? So one side you have dashboards that you're being shown to a user, which have a certain kind of importance or a certain query shape. Another, you have like monitoring and alerting, which is super important. But the interesting thing is monitoring and alerting, for the most part, looks at only very, very recent data. It doesn't go back very much in time. So you have maybe a different profile of how you want that system to operate. Then you have like large scale analytics, which access larger portions of historical data. Those are queries that typically take longer to run. You don't want to, muck up your monitoring, alerting, and your dashboarding infrastructure with the stuff that's processing that. And then at the very end, I always think about the queries that you need to perform for machine learning tasks, for either training models or pulling in data as you're making predictions. So being able to have a production infrastructure where you have different setups for different query workloads, I think is really nice. It gives you better flexibility. And the way to do that is to have a storage system that is separate from those servers. And then the other thing is, like, at this point, object storage, or basically the S3 API, has just become something that's kind of universal. There's something like that available in every public cloud. Most people I know who are running their own data centers have something like that available. So it's basically just like a lowest common denominator that we can count on, right? You can count on a Linux stack being available, and you can count on object storage being available.
Yeah, that completely makes sense. I have more questions, but the audience has questions, so I'm not going to be so selfish. I'm going to let them get their questions answered. So, Paul, can you see the questions that have come in for you?
I can, yeah.
All right, I'll
Should I
let
just,
you read them out loud and yeah, answer them, and then I'll go last for a change.
sounds good. Thanks, Chris. So the first question, how will InfluxDB IOx change the experience and capabilities for existing InfluxDB users? So as I mentioned, obviously multiple times, the elimination of cardinality is a concern. I think will change the way that people interact with the database. I think that's super important. Obviously, having a standards compliant SQL implementation will probably change the way people query the database, even though we obviously will support Flux and InfluxQL as well. The embedded JavaScript engine, I think, is super interesting. We're likely not going to get to that feature until towards the end of this year or maybe early next year. But it's one of the features that I think is core to IOx and how it will operate at the edge. Basically, like once you have that, essentially you can do anything with it. But it'll allow you to connect to other third-party systems, to have arbitrary data processing that happens on the data as it arrives and close to where it lives, so that hopefully it'll be performant and super fast. All right, so the next question, will InfluxDB IOx replace InfluxDB? As I mentioned, it is basically the new core of the database. Now, InfluxDB as it exists today is really a lot more than a database, right? So our cloud product, which we call InfluxDB Cloud, right, is way more than a database. Typically, when you think of a database, you think, I'm going to write data, store it, and query it, right? Now, InfluxDB Cloud has this whole user interface. You can define dashboards. There's a feature called Notebooks where you can basically interactively explore your data and create visualizations and create other things in the system. Namely, there's the tasks system, which allows you to define arbitrary processing that happens in the background. Right now, this happens with Flux, but we're going to be adding language support for Python and JavaScript over time. There are other features coming up like functions and other things like that. So all of these things, basically, the goal with InfluxDB as a platform overall is to make it easy to not only store and query time series data, but also to define processing rules that allow you to monitor that data as it arrives or periodically, and ideally to take action on that data, right? To trigger automated systems and all this other stuff. So the task system, the dashboarding, like all that stuff is kind of outside the core of the database. IOx is essentially the new core of the database. Now, it's going to take time to develop. So there's going to continue to be multiple releases of InfluxDB open source in the 2.x line. And then at some point, there will be a point release where InfluxDB 2.x will be able to use IOx as its backing store. Now, by the time that happens, in our own cloud environment, we will already be running InfluxDB IOx in production for most, if not all, of our customer workloads. So IOx as a piece of software will be heavily tested. It will have a lot of production time behind it across many different use cases and customers. And the thing is, we can do this within our cloud environment because the InfluxDB cloud products, like I said, isn't really a database. It's this larger like SaaS service where one component of it is the storage system. And IOx is replacing that storage system. Actually, it's going to be running in parallel with the other one for a while, and then over time replacing it. Okay, what is the relation between IOx and Flux? So Flux is our kind of a combination scripting language and query planner and processor. Now, Flux is written entirely in Go. Well, there's one part of it that's written in Rust, which is like the parser and the semantic type checker and all this other stuff. But The majority of Flux code is written in Go. And obviously IOx is not written in Go. So, but we need IOx to support Flux as a language. And we also need IOx to support InfluxQL because, we have tons of customers and users. They've written, many, many thousands of lines of code in these things. So how the two connect together is you will have a Flux processor, like a process that's in Go that has the standard like Flux API, and it will be able to call out to IOx to use as the storage layer. This is actually how our cloud environment works today, right? So if you're using our cloud and you submit like a Flux query or an InfluxQL query, if it's Flux, it goes to one set of query processors that is Go process. If it's InfluxQL, it goes to a separate set. And what they do is they make a call down into the storage layer. And the storage layer has the TSM storage engine and this like gRPC storage API. So what we've done within IOx is we've mirrored that API so that Flux can connect to it the same way it connects to our current storage engine and cloud. Now, over time, what I expect to happen is Flux will be able to actually start taking advantage of the IOx native API, which is Apache Arrow Flight and SQL. And what I think will happen is Flux will push more and more of the declarative query processing down to IOx, and then Flux itself will become a processor that's largely just a scripting engine that can understand the Flux language and interface seamlessly with IOx, which is the storage system. So on the query path, what do you see as being first-class citizens? For example, is it still worth investing time in mastering Flux or stick to SQL? This is part of our new philosophy, which is polyglot query and polyglot programming. Essentially, we want you to be able to use the tools you want to use. If you like Flux as a language, use it. We're going to continue supporting it for years, right? Flux will be a first-class citizen in terms of working with data in IOx. But if you would prefer to work with SQL, you can do that. Now, as I mentioned, Flux is a lot more than just a declarative query language. It's a fully functional scripting query language, right? You can interface with other third-party data systems in addition to actually querying the data. So it also kind of depends on what you're trying to do. There are many operations that you can express in Flux that are simply impossible to do in SQL. So it kind of depends on what you prefer. All right, so next one. So should people remain on 1.x and wait for the IOx version, in parentheses, InfluxDB v3, and skip the 2.x release? I think you should upgrade to the 2.x release if it has features that you want. If it has features that you consider useful to you, upgrade. If 1.x is working for you and you're perfectly happy, continue to stay on 1.x. It really just depends on what your needs are and what your use case is. But if you, like I said, if you want to get the best out of Flux, that's going to be on 2.x. If you want to get the notebooks feature and some of these other things, if you want to get tasks, that's on 2.x. So if you upgrade to 2.x, we're going to continue to support that, obviously. When IOx comes out, there will be two pathways to get it, either just IOx itself, or if you're running 2.x, you'll be able to use IOx as your storage system. And like I said, we'll have automated migration tooling to be able to move the data over. The nice thing is we've already created the mapping of TSM data over to IOx so that we can be sure that we support all of the things that it does. Do you have plans on removing the support for InfluxQL in the future? We currently have nothing planned. Right now, our plan is to support it. As long as people are using it and enjoying using it, we're going to support it. So that's the plan right now. Do we have improvement over Influx 1.x or 2.x regarding delete and drop metrics? Are we still using tombstones? So IOx will use tombstones. The reason is deleting is an expensive operation, and you don't want to do this in your production infrastructure. So depending on what you're doing, this is either good or bad. So the way tombstones will work in IOx is probably quite a bit different than the way tombstones work in the TSM engine. So your perception of what the performance characteristics of this thing, what tombstones are, and what they do to a production database are probably not applicable to the way IOx will work, right? Tombstones will get it written in and they can be applied at query time. But again, because we've decoupled compute from storage, if you want to process that tombstone, you'll actually be able to process the tombstone on totally separate infrastructure that's not dealing with your query workloads. And you'll be able to process the tombstone, basically rewrite Parquet files where you're deleting data. But the other thing is, our hope is that because you're storing data in object storage, which is way cheaper than storing it in a locally like EBS or something like that, like significantly cheaper, we're hoping that you won't have to delete data. Now, obviously, there are issues with like GDPR and stuff like that. So deletes need to be able to happen, but our goal is that you'll be able to decouple that process of resolving the deletes and processing the tombstones against the actual data separately from your production query stuff. So do we already have a performance comparison between current latest InfluxDB and InfluxDB powered by IOx? No, we don't. And we probably won't have that for a little while. So that's just kind of like the stage of where we are in the project. The first performance comparisons we'll be doing extensively are basically within our own cloud environment. And we're actually kind of doing that already, but we're going to make that more repeatable where we have, a performance dashboard and we can track for regressions and stuff like that. So we're going to have kind of extensive performance comparisons between the two, but most of the stuff that we're going to do, I'd say within the next 5 months, is really focused on our own cloud environment and less so on the open source builds. Like I said, the open source InfluxDB backed by IOx is probably a decent amount further out than IOx being launched within our cloud environment. What about the updatability of data? How hard or easy is it to mutate data by just using native queries or scripts? So I have maybe a controversial view on updates, particularly in the realm of time series. So I don't think you should be doing updates ever in time series because an update pretty much amounts to rewriting history. To me, time series data is essentially observations of history, whether it's in a virtual system, the physical world, whatever. Now, you can certainly update those observations, but it doesn't mean that the original observation you took should be updated. The new observation should be written in with a new timestamp that back references the original observation that you took. So ideally, what we'll have is a system where you can write that data and not have it be super expensive to store and keep around, and you'll be able to query and work with it at the same time. Now, that being said, we have to support updates. We have to support upserts. The primary use case for us for this is essentially idempotent writes, right? So what that is if a client like Telegraph is writing data and it's providing the timestamp of that data, sometimes you're going to have a hiccup in the server or the service where it gets a write like partially done, or maybe it gets a write and it doesn't get a success response. So what it does is it basically just posts the exact same thing again. So we need to be able to handle that, which means we need to be able to handle updates. But that is kind of the way we do that, the way we'll do that and optimize for that is kind of different than if you're, say, updating data that you wrote in yesterday or last week or last month. Again, we will still support it, but it's not what the system is optimized for. Will IOx feature more data types? We're particularly interested in arrays. Yes, we want it to feature more data types. That is the plan. But before we get to that, we have to make it really, really good for what InfluxDB currently supports. So my guess is additional support for new data types is not coming anytime this year. I'm not sure where on the product roadmap that would be. We absolutely want to support more data types. I just couldn't say with any certainty when that's going to be coming. This is a good one. Why did you choose JavaScript and not Flux for what they're calling stored procedure, the embedded scripting language? So we need to be able to embed it within IOx, which is written in Rust. Flux is written in Go. So we can't use it as an embedded scripting language really at all. So basically, like, in my mind, there are probably two options we could have picked for an embedded scripting language within a Rust project. And basically what you're doing is you're embedding a C or C++ engine, an engine written in C or C++. So Lua is obviously a very popular choice for embedded scripting, but JavaScript, I think, is the more popular language, and TypeScript that comes with it. The reason is basically the popularity of the language. It's familiar to the vast majority of developers. There are a number of implementations that we could choose to import. But the other nice thing is there's a project within the Rust community called Dino. It's Ryan Dahl, the guy who created Node.js, and a number of other people have created Dino as a project. Some parts of it are written in Rust, and it's basically an easy way to import a JavaScript engine into a Rust process. So our intention is that we will use Dino for that JavaScript processor. So basically it's a matter of ease and a matter of what was available and what made sense. So will IOx be available to enterprise customers and when? Yes, but we do not currently have the specific dates planned. I can't particularly say that. But if you are an enterprise customer and you're interested in this, I would say you should reach out to our sales team or your sales rep to ask more about it. And potentially you can get a one-on-one with me and some of the other people. All right. By the way, how much do I have, like, all this time to do Q&A? Somebody gonna like, okay, great. I can keep going. Yeah, I still have coffee left in my cage mug. So, all right. Could you talk a bit about the partitioning of data? The examples you gave are based on time, but can it be done in non-time ways? Yes. So the partitioning rules essentially can be based on whatever it is. It could be based on like a column value, right? So generally what I would expect is that you would base it on a column value and time. So for example, if you were writing in a bunch of data and you had the region the data was coming from, so you want to partition based on the region and time. But technically you will be able to work with IOx and partition based on other things. But the thing is, like, again, because the goal here is really about time series data or about historical data or event data, time is usually going to be a part of it. And that will actually make it easier for us to, like I said, create these immutable blocks of data that allows the system to optimize over time. So because we don't want to reshuffle and rework with, historical data. But again, the goal will be that you don't necessarily have time you don't necessarily need to have time as a column within the system. Now, if you're working with Flux and InfluxQL, they have a hard requirement that time is there. But if you're using, and same thing with the line protocol that you're writing in. Now, if you're using the native IOx write API and you're using the SQL engine, that won't have a requirement for time. How long do you plan to maintain 1.x? I actually do not know the answer to this question. I think there is an answer to this question, but Tim Hall and Ryan Betts will be presenting tomorrow. Tim Hall's our head of products and Ryan Betts is our VP of engineering. They will be talking about roadmap and that kind of stuff. And I think they may be touching on how, maintenance plan for 1.x and stuff like that. So what granularity are you able to manage memory, like write through versus write back? And would that be partition based? So the way the system works right now is the memory numbers are estimates. We make estimates for how much memory each thing is taking. And that's based on a chunk. So like I said, we have the database, the partitions, the tables, and then chunks beneath that. So you will be able to drop specific chunks out of memory, or you'll be able to drop entire tables out of memory within a partition, by the way. So, or you can drop an entire partition, right? So all of those like different levels will be accessible to you. Again, the goal there is to provide as much control for the operator through the API so that you can have, you can totally customize the data eviction process for your needs, which is where, again, that's like part of the philosophy for why we have the data plane separated from the control plane. We wanted to be able to iterate on these two things separately. And what we realized over time, watching people use InfluxDB over the years, is that the control plane needs for one use case are very, very different for another. So separating that out made more sense to us, because what that means is you can build a totally custom control plane that meets your needs. So IOx was first presented as only a new backend option for InfluxDB. Seems more it will create a new product from zero. New product or extension to InfluxDB 2. So it's basically an extension to InfluxDB 2. As I mentioned, it represents the new storage system within our cloud environment. So first and foremost, that's what it needs to be. It needs to be a useful piece of software that we can use to improve the production cloud system that we're running, right? So initially, the way it will look to our cloud customers is it won't look like anything at all. It's just a new storage system. It's going to be some upgrade that happens in the background. And basically what's going to happen is they'll no longer have to worry about cardinality. Hopefully we'll be able to provide better pricing in terms of what storage costs at rest. They'll get faster query speeds, right? These are all improvements that we want to make to our cloud service, regardless of whether or not we are developing IOx. The decision that we made early on was to create IOx as an open source project and to do this development out in the open. And this was something that we discussed as executive team, as a product team. This was discussed at multiple board meetings about whether or not we were going to do it like that, right? We already knew we had to develop a new storage system for our cloud environment that achieved these goals, right? Tiered data storage, high cardinality, all these other things. The question was, how were we going to pair that with our open source efforts? And we decided that we wanted an open source project that was permissively licensed, where we were doing this development out in the open. For me, it was actually personally important because this is how InfluxDB was developed back in 2013 and 2014 when we first started out. It was done out in the open early on, and I was super excited about that mode of interacting with the community. So, new product, IOx will have its own builds, right? So I guess in that sense, it is kind of a new product, but again, it's meant to be an extension to InfluxDB 2, right? So as a user of InfluxDB 2, you can use IOx. But if you're brand new coming in, you can use IOx in isolation. So do you plan to support multiple time indices for prediction data, having predicted time and the time of creating the prediction? So as I mentioned before, we don't really have indexes. We have partitions of the data. Now, you can definitely have multiple time columns, and like a datetime type is going to be a separate type rather than just like an int column or something like that. So you'd be able to have like the time of a prediction and the time of the original observation or something like that. But again, because the data is partitioned in a certain way, how the query engine works is it looks at the query and it determines which chunks of data need to be evaluated. And those chunks are organized basically based on partitions. So you could add some sort of secondary indexing separately. Again, this is the advantage of having all the data in object storage in a file format that you can read and write in multiple languages, Parquet. So if you wanted, you could create a totally separate secondary index from the system. But depending on the delta between your two different timestamps, you may not need to do that. Maybe the one partitioning scheme is enough to get you what you want. So will IOx also extend the ability to query beyond within a measurement? Flux allowed some joins, but will IOx allow to go further? So joins are absolutely a part of IOx. Joins are currently supported. They're not super sophisticated at this point. The join functionality is obviously going to get improved over time. I'm not sure what specifically you're trying to do, but joins that you can do, the goal will be joins that you can do in SQL, you'll be able to do in IOx. But if you look also at us having an embedded scripting engine, worst case scenario is you could query data in the scripting engine from IOx all within memory and then do the join or whatever you need to do within JavaScript rather than doing it in SQL. Or you could also do it in Flux, right? Because you can write Flux, and like I said, Flux is a scripting language, and it can query IOx, and then you can do that kind of stuff within Flux itself. So does IOx affect how fine-grained authorization and or multi-tenancy is handled? Multi-tenancy, yeah, that is actually one of the project goals we had, is that we would be able to achieve tenant isolation at the storage layer for tenants who wanted it or needed it because of their workloads. And again, this is part of the decoupling compute from storage that gives us greater flexibility. So multi-tenancy is, I think, something that is easier to achieve in IOx. But the other thing is, like, part of the multi-tenancy story that we have with IOx is we're going to use the tools that Kubernetes provides to build a multi-tenant platform, right? We don't want to write multi-tenant code if we can offload that concern to Kubernetes and let it do the heavy lifting for us. Fine-grained authorization, IOx itself doesn't have authentication and authorization. That occurs either at the InfluxDB layer or within our cloud environment at a service called Gateway, which is essentially the API gateway that does authentication and authorization for us.
Wow, a lot of questions, Paul. That's that was really good. Yeah. I actually have a couple comments and a question. I think looking at some of the questions that came through, I'm going to guess that the kind of the underlying question that a lot of people had is, are there going to be any kind of big breaking changes that they should be worried about, right? I'm going to guess that's why people brought up like 1x, 2x, the possibility of changes with IOx. Are there big changes that they should be concerned about?
No,
that would break
no breaking changes.
Things?
Yeah, there are no breaking changes that we foresee. Again, like the goal was a data model that maps cleanly so that we can have this as additive functionality, not as a breaking change. Now, to use IOx, a data migration will be required, obviously, because you're migrating from the TSM storage engine to IOx itself. But everything just needs to work, right? And again, this is part of the reason why we're deploying it into cloud, right? So we deploy it into our cloud environment, and basically what those users are going to see is they're going to be querying it via Flux and InfluxQL, right? And they're going to be writing that data via the LIME protocol. So the way they interact with IOx within our cloud environment is the same way they interact with it today, which means we can't break things. It just has to work. So cool. That's the way it's going to be deployed.
I think that's really important, just to reiterate to everybody. And then I think the other thing that's I want to reiterate to everyone is that we are putting that into our production cloud environment. And so we're essentially the first consumers of this. So hopefully we'll, if there are any issues, we'll find it first and we'll address them. So by the time you're ready to put it into your production environment, it should be in pretty good shape. Wouldn't you say so, Paul?
Yep. Absolutely. Like I said, we're currently mirroring a production workload onto it and testing it. So,
and then I think the final thing that that you mentioned that I find very admirable is that, we could have just built this backend stuff in our cloud environment so that we can have that unlimited cardinality and just called it a day. But I think what's really impressive, and I think it speaks to the values of the company, is that Paul decided that he wanted to make sure that IOx is an open source project. It's completely in the open. Share the journey, share the bumps along the roads, right? It's not going to be a perfect journey, but I think this just is a testament to who Paul is and who we are as a company, that it's really important that we share this in the open. And so kudos to you, Paul, on that. And of course, the entire IOx team. And I'm sure the community is really appreciative of your openness and this whole journey that you're taking us on. One last question. I think the most important question everyone has is there now, I think people are now betting to ask what is the next hair color that we can anticipate Paul to have in, in one of the upcoming talks. So any clues on what color we might be able to expect?
So that's a good question. I don't know. So I really missed an opportunity here because this hair color was actually motivated by my partner. She wanted me to do something for my birthday, which was recently. So she picked the color. I mean, she's the colorist. But I think the missed opportunity I had was I could have done InfluxDays colors, which Emily reminded me of. So who knows? Maybe green is the next one.
Cool. Well, everyone put your favorite color in the Slack channel. And speaking of the Slack channel, please join not just the community Slack channel for InfluxData, but also the IOx Slack channel or Flux. There's a bunch of teams that are in there. We want everyone to join in on the conversation. Also, just want to remind everybody, all these sessions are being recorded, and we'll make sure that we get the recordings to everybody so you can take another listen to it. If you're keen to learn more about IOx, join us on a monthly basis. Paul and the team are sharing all their progress every month, and we get a nice set of questions at those sessions as well that really helps to illuminate the great work that they're doing. The other thing is we have trivia later on today, so please join that, but it's at the same time, at a competing time with the IOx office hours. So if you find yourself coming up with more questions about IOx that you want to ask Paul and the team directly, please go ahead and join that office hours. And the way that you can find those office hours is if you scroll down in your Convene app, you should see the office hour time, and there'll be a button when office hours is live that you can click on, and it'll take you into a private session with Paul and the team. The other thing is we have the Influx Challenge going on, and if you take a look in the Slack channel, you can see there's a couple people I think that have completed the entire challenge. But it's okay. Everyone else can still participate. Of course, great swag as prizes. So we want to make sure that everyone can learn from each other and check out what are some of the responses to the challenges. And then finally, just want to remind everybody, there's lots of training opportunities and webinars with us. So that's just a quick shout out on the things that we've got going on.